Welcome to RFID for Beginners++. And as my CEO pointed out, it's RFID for Beginners++, not RFID for Beginners++. Semantic differences, they're very important. So, 20 minutes turbo talk to cover the theory, the design, the operation, and the mathematics of RFID systems. Not gonna happen. This was originally supposed to be like a double talk, back-to-back, lots of content, and for some reason that didn't happen, and it came down to a 20-minute turbo talk. So, yeah, it's somewhat truncated. It was also supposed to include the design and operation of Cloner 2.0, which is a 75-minute presentation in itself, and yeah, that's not going to happen either. So, start out talking about what happened in DC and why I'm not giving a 150-minute presentation. Lots of legal nastiness. A certain company threatened patent litigation. ACLU got involved. Homeland Security got involved. US CERT got involved. Lots of legalese flying around about patents. Look it up on Google if you're interested. I won't repeat it all here. The upshot of it all was that we were looking down the barrel of potentially $10 million in legal fees to get a patent lawsuit dismissed that was completely baseless. And, you know, I don't care how elite you are, if you're a 30-man outfit, you cannot afford $10 million in legal fees. So we couldn't risk it, we pulled the talk. However, we've reached somewhat of an understanding now. We can now demonstrate the devices, we can talk about them, we can actually use them a little bit, but I can't give out schematics and I can't give out source code. And there is a certain vendor who will remain nameless throughout this talk, who I'm certain you can find out who it is if you don't know already. But yes, they will be nameless, completely. So, given that I've got 20 minutes to talk to you, I want you to imagine, if you will, that I've just delivered an eloquent, technical, desperately insightful presentation about how RFID works. About all of the theories behind it, how it's not an actual radio transmission, it's an inductive coupling. So if you think of it less as a radio transmitter and a radio and more like a transformer, you're right on the money. How, you know, the PIC microcontrollers are ideal for this kind of work because they've got lots of input-output pins, lots of capabilities, timers, all kinds of things that are great. You know, I've talked about RF modulations and amplitude modulations and FSK and FC810 encodings, and yeah, just imagine all of that. Also, imagine that I have explained in great detail that any 125 kilohertz proximity badge system is vulnerable. Indala, Motorola, Hitachi, others. If you are using 125 kilohertz proximity badges, such as this one, which you cannot see the logo from there, your doors are highly insecure. So, let me skip to the fun bit, the demo time. Toys. So, this was the first cloner. This was the one that I demoed at RSA, the one that got us into some trouble. And it's very simple. You push the red button. The red light comes on. That's in read mode. So you wave the card at it, and you see the green light comes on, showing that it's detected the card. And then in theory, if I kind of wave the card in the loop somewhere, the lights go out. It's copied the card. Simple as that. That's all it is. And then here, I've got completely standard USB RFID reader. It's not branded by anyone you would have heard of, but it was like, I think it was like 20 bucks from Radio Shack or something. So you swipe the card across it, light goes green, code comes up. Very simple. Throw the card away. Take the cloner, push the black button, swipe the cloner. Light turns green, code comes up. We've copied the card. Thank you. So, the other things that this can do, if you actually push both buttons, it commits the code to flash memory. So if you need to change the battery or do something else, you can do that, and then you put the battery back in, and you can still, eventually, hopefully, replay the code. So, the big problem with this one, This was designed as a teaching tool. This was designed for BlackHat DC so that I could pick it apart and explain everything about how it works. So it's very, very simple. Enter Cloner 1.1. This is basically the same circuit. This is a development board though, so it's kind of messy on the flip side, and yeah, there's no box around it, but essentially it's the same circuit. I've just taken a lot more care over tuning the various components in it. The RF stage is much better. There's a bit more power going through the coil. It's just overall slightly tweaked. And the great thing about this one, let me put it here so I can kind of show you. If I put this one into read mode, move that away, it confuses it. Oh, through that kind of far. I don't know if you can see the green light from there, but the green light comes on at much greater range, and it reads the card from much greater range. So you've got a good few inches of range on this one. It's not quite that you have to kind of fumble with someone's pocket and they wonder why you're groping you in an elevator. You literally can. With this, it's the same circuit, it's just slightly tuned, and it's got much, much better range, a good few inches. So that's Cloner 1.1, and again, I'll do it the other way around because the circuit's a bit fragile. If we push the playback button and then swipe the reader, again, it plays it back. So it does exactly the same thing. So, yes, I wasn't lying. I have built RFID cloners. No, it wasn't faked. Despite statements made to the press by certain nameless vendors, it was not staged. Another interesting point to note. Anyone seen these things before? RFID shields. Like tinfoil wallets and little flippy open case things. The idea is, you take your card and you put it in a tinfoil wallet. Now, these are actually commercially produced. These are from a company called Identity Stronghold. We've been giving these away at our booth. These are FIPS approved. They're government certified. They are as good as it gets in terms of RFID shields. Light turns green, code comes up. So let's scrap that idea, skip back a few slides, go back to Notepad. So this one, this is the premium version. So you put that in there, and the idea is when it's closed, you can't read the card. When it's open, you can read the card. So we'll leave it firmly, in fact, we'll hold it closed, firmly closed. Bugger. The problem with it is, when you're talking about 125 kilohertz, you're talking about a lot of power. It's extremely difficult to filter it. You really cannot block it. The company that makes these things, I was on the phone to their CEO the other day, and he said to me, look, you know that these don't work at 125 kilohertz, right? I was like, yeah, so what does? He's, well, I don't know. We haven't figured that out yet. They're working on an active device that will generate a confusing signal. It'll effectively jam it. So you'll have a second device in your pocket with, a 125 kilohertz emitter that's actively kind of fuzzing the spectrum, trying to prevent people from reading your RFID. It's wrong. Just scrap the stuff. Just get rid of it. Anyway, these things, they're great at higher frequencies. If you're up in the megahertz range, which most of the newer RFID stuff is at, they work fabulously. So we've still got a whole bunch left over. Hopefully someone from IOActive will take the hint and run up and get some and have them by the door when we leave. Yay! Thank you, Damon. So yeah, higher frequencies are great. So they're great for credit cards. They're great for everything except 125 kilohertz procs. It's bad. So yeah, we've improved the range on Cloner 1.0, so we're at kind of 1.1 at the moment, and we're still going. Cloner 2.0 is in development. Unfortunately, billable work is kind of necessary sometimes, so the RFID research kind of got put on the back burner a little, given that I only had 20 minutes to talk about it as well. So some things that it's kind of doing but not quite properly yet. significantly improved read range even from this. It'll read cards about here. So it's a pretty decent read range. It's got multiple radio front ends. So this particular brand of card that's now over there somewhere, it's 125 kilohertz, but there's a lot of other different ways of modulating the data onto that 125 kilohertz carrier. So it's got multiple different decoders, demodulators at the front end, so it'll also read Indala tags in addition to the cards with the tag that you can't see the brand from there. So it's also got an enhanced microcontroller, so it's got much more capabilities in terms of finding the data format. If I get sufficient energy to do it, I might even put in a brute force mode, because the card IDs in these are actually incremented. They're sequential. So in theory, you can grab one badge number to get into the building, and then if only certain badges within the organization have access to the server room, you can just brute force it. It's not difficult to do, really. Another fun thing that Cloner 2.0 is doing, it has a passive mode. So what primarily limits the range of these readers is the fact that this coil on the reader needs to power the card. So there's fundamentally a lowest threshold of power that you have to have. So either you're putting out so much voltage through this coil and so much power that it's getting dangerous, or you let someone else power it. So the idea would be, you take Cloner 2.0, drop it in a bush by the back door. Someone comes along, scans their card. Oh, stop it. Someone comes along, scans their card, the reader provides the power, and I just get a very, very small signal that I can amplify up significantly and recover the codes. So, as I say, drop it in a bush, come back a couple of days later and recover all the codes for everyone that's gone in and out of that, or gone in the door at least, for the time it's been there. Aiming for 10 feet range on that. Might not get there, might be better than 10 feet, but that's what I'm shooting for. So, reading RFID tags passively at 10 feet distance. It'll also have a display and keypad for the retrieval and entry of codes, so you don't have the ability to just store one code in Flash. You can put them in and read them out at will. Hopefully it'll be ready for BlackHat 2008. Anyway. You can have schematics? No. Bad people. All of you people who've been asking me for schematic, stop. I cannot give out schematics. However, Jonathan Westhuse, he built a Verichip cloner. And strangely, his circuit looks remarkably similar to this. In fact, coincidentally, he actually uses the same PIC microcontroller. And he also has 2 buttons and 2 LEDs and a couple of transistors, and has some things in common with mine. The main difference with the Verichip cloner is it uses a different modulation scheme from these nameless cards. So that's a good basis for the framework of the cloner. The third link down is a microchip reference design for an RFID reader. So the guys that make these microcontrollers actually said, hey, if you want to make an RFID reader, here's how to do it. Here's the schematics. Unfortunately, their circuit is kind of ugly. It's inefficient and uses way more components than it needs to, so it'll work, but it's going to cost you a bit of money. Maybe $12 instead of $10. So basically, if you take those two and spend a week on it, if you've got kind of high school level electronics, those two will be enough for you to build this device. The protocol documentation is also public, and yes, I'm right in saying